Okay, so this video right here is going to end off chapter 5, and today we're going to be talking about the supply of labor, and we have to look at this at the worker's perspective, okay? So why do you think workers want to work? Well, for an obvious reason, it's because they want to get paid, right? And workers typically get paid a nominal wage rate, which is represented by a capital W. And once these workers get paid, they are going to use that to buy goods and services to consume. Well, that's because when they consume goods and services, they become happier, right? So let's assume that all the goods and services can be combined into one good, and that is called a composite good X. And the price of all these goods and services is indexed at a level of Px. So with that said, what workers really care about is their real wage rate. So we talked about real income in chapter 2, so the real wage rate is something similar. So you take the nominal wage divided by the price of X, and you're going to get small letter w, which represents the real wage. Okay, so when workers are not working, what are they doing? Well, they are having fun, right? So we say that they are having leisure. Let's represent leisure with LE. And what do you think is the price of leisure? Well, the price of leisure is actually the nominal wage rate, capital W. Why? Well, that's because this is actually opportunity cost for not working. When you're having fun, you lose what you could have earned by working that few hours, right? So let me ask you this. Do you like goods and services? Well, of course you do. And do you like leisure? Well, of course you do. Who the hell does not? And the next question is, are goods and services and leisure scarce? Well, of course they are. There's a limit to how much you can get of both of them, right? Therefore, good X and leisure, they are economic goods. Okay, they're economic goods because they are scarce and they are desirable. Okay, so now that you have understood that, let me ask you, do you like to work? Well, I don't really think so, right? Nobody really likes to work, and we are not talking about a scenario where there's really high unemployment, and we're also not talking about individuals who are workaholics, right? So we don't really like to work. So now that you understand what workers like and don't like, you can now derive the worker's utility. So the worker's utility is simply made out of the things that they love, right? It's goods and services, good X, as well as leisure. So this actually gives you a concave utility curve or an indifference curve, which you have learned in chapter 2, consumer theory, right? So we're going to apply that concept here. Now let's look at the budget constraint of the worker. But before we get to the math of the budget constraint, I need you to understand that leisure actually has a fixed scarcity. So what does this mean? Well, I'm going to use a numerical example to explain the concept of fixed scarcity. Alright, so how many hours do we have in a day? Well, we have got 24 hours in a day. And let's just assume that we spend 8 of that 24 hours sleeping. I mean, everybody needs rest, right? Unless you're Superman or something like that. So you have got 16 hours left. So let's assume that you do nothing but work and play. So you need to allocate some of that 16 hours for labor, and you need to allocate some of that 16 hours for leisure. So this is where the concept of fixed scarcity comes in. So take note of this 16 hours left. So the choice of leisure hours and of course to work is actually restricted or fixed at 16 hours. So you only have got 16 hours to make a decision as to how much you want to work and play. So that is what we mean by fixed scarcity. So this 16 hours here, let's just denote it as L bar. So how do we calculate the number of hours that we work? Well, it's quite simple. You just take the total number of hours that you have minus the total number of hours that you're having leisure. So the remainder is simply the number of hours that you work, right? So with that, it's going to be very easy for you to calculate the total wage of this worker. You simply take the wage rate and you multiply that by the total number of labor hours, which is L bar minus LE. See? Simple, right? Okay, so now that we understand this, we can finally go write out the budget constraint in terms of math. So in order for this individual to maximize his budget, all the stuff that he spends on goods and services has to be equals to the amount of money that he earns, right? So on the left hand side is his total expenditure on good X, which is simply the price of X multiplied by X, and this has to be equals to the total amount of money that he earns, which is the nominal wage multiplied by L bar minus the amount of leisure that he has. So we can actually rewrite this equation into the price of X multiplied by X plus capital W times LE equals to capital W times L bar. So I think you will notice that this is actually very similar to the budget constraint that you derived in chapter 2. Okay, so now that we've understood this, we can now go to the graphs and find out how we analyze a worker's choice between good X and leisure. So as you can see, I've got leisure on the horizontal axis and I've got good X on the vertical axis. Remember here that good X represents all other goods. Okay, so if we had 0 hours of leisure, so this guy's a freaking workaholic, so the budget constraint would look something like this. Therefore, the total amount of X that this individual can get would be simply this. The wage rate multiplied by L bar divided by the price of X. So this is the maximum amount of X he can get if he had no leisure at all. So this guy is working his ass off. So if he chose not to work and just play all day long, he wouldn't have any money to buy X, right? So we can actually use this to find out the maximum amount of leisure that he can get. So to find the total amount of LE is simply rearrange the budget equation to get L bar. So the horizontal intercept is simply going to be L bar. Okay, and the next thing you can do is just combine both of the intercepts together, and now you need to find out what is the angle of this slope. So remember in chapter 2 you have px over py, right? So what is the price of the horizontal axis variable? It is simply the nominal wage. And what is the price of the vertical axis variable? It is simply the price of x. So w0 divided by px0 simply gives you your real wage. So that's the budget constraint, ladies and gentlemen. So we can now add in the utility curve, and obviously you would know this by now. The individual would maximize his utility given the budget constraint, and he will be at point A. So being at point A simply means that he would choose x0 and L0 as a bundle of good X and leisure to maximize his utility. Okay, so from here you can see that from L0 to L bar, this is where he is working. And from 0 to L0, that is where he's having fun, he's having leisure, right? Because the more you go towards the right side of the horizontal axis, that's where you're having more leisure. Okay, so the fun plus the leisure is going to give you your total number of hours available. So that is actually L bar. Now, what if I'm going to impose some kind of a travel time of T0? So he needs to take T0 amount of time to get to work. So what's the budget constraint going to look like? Well, basically what this means is that he has got lesser time available for work and play because he's going to need to travel, right? And he also has an excuse to be late for work. Okay, so let's take the total number of hours and we now have to cater T0 for him to actually travel. So the total amount of hours he has left to work and play is simply going to be L bar minus T0. So the travel time could be for anything. It could be traveling to work, it could be traveling to have fun. Okay, so now let's take a look at what the budget constraint is going to look like. So let's just draw the original budget constraint so that you can see the differences. So in the past we had L bar as the horizontal intercept. Okay, so now this individual only has got L bar minus T0 to determine whether he wants to buy goods and services or he wants to play. So take note that his real income in terms of X has also decreased because you need to deduct T0 from L bar. So he has got lesser time to work means that he has got lesser nominal wage. So as you can see, there is a horizontal and vertical shift of the budget constraint. So it's a parallel shift to the left hand side of the graph. Okay, let's make things a little bit more fun. What if I have to pay C0 per amount of travel time? Well, the first obvious thing that's going to happen is that the vertical intercept is going to go downwards. Why? That's because inside the bracket terms, you need to multiply T0 by C0. So that is the total amount of travel expenditure that this individual is going to incur. So when there is a expenditure for travel, then obviously the amount of wages he can earn will definitely fall. So this explains why the vertical intercept is going to move down. To find the new horizontal intercept, you need to assume that you have 0x. So when you have 0x, this is what happens to the budget constraint. Now, take note that the budget constraint is going to look a little bit different. In this bracket, you need to minus T0 because you will have lesser number of hours available to work. And you need to minus the entire right hand side by T0 times C0 because that is your total transport cost. So what you want to do now is to rewrite the entire equation. So I'm going to divide both sides by W0. So I'm finally going to get this. So notice that now there is an additional subtraction of T naught times C naught divided by W naught. So this is simply the time spent working so that the individual can cover his transport costs. So as you can see, the new horizontal intercept is now closer to the origin because as compared to L bar minus T naught, you now have an additional term that you have to minus off the entire equation. So that is why your budget constraint is now going to shift in a parallel fashion to the left hand side of the graph. Okay, so I've actually shown you some of the dynamics when there is a change to L bar, or anything happens to L bar, like maybe there's like traveling time or transport costs and things like that. Okay, so you now understand the dynamics when there's things happening to L bar. So now let's look at the dynamics of this budget constraint when you have changes in the nominal wage rate. Okay, so we're going to assume here that there's not going to be no change in L bar. So let's take a look at what happens to the budget constraint. Well, actually this is actually quite simple. You can either have an increase in the nominal wage or a decrease in the nominal wage. Okay, so when the nominal wage increases, you're going to get a steeper budget constraint and a higher vertical intercept. And take note, when this happens, the horizontal intercept is still the same because there is no change to L bar. So you have a steeper and higher vertical intercept because when your nominal wage increases, obviously you're going to be able to afford more of good X. So when the nominal wage falls, then what happens is that you're going to have a flatter budget constraint and the vertical intercept will be lower. And that's because with lesser nominal wage, obviously you can buy lesser X. Okay, so just let me briefly run you through the graphs and what it will look like. Just take note that the budget constraint is going to pivot along it's going to pivot on L bar because L bar doesn't change, right? So this is our initial equilibrium, and take note that the vertical intercept is also similar to the real wage multiplied by L bar. Okay, so the individual is going to maximize his utility by being at point A. And let's just say that the nominal wage is going to fall, which also causes the real wage to fall. So what you're going to have is a flatter budget constraint and the vertical intercept is going to fall, as what you see in the diagram over here. And if you go the other way around, your real wage is going to increase, then the budget constraint actually becomes steeper and you have a higher vertical intercept. So you see, it's actually quite simple. But in the case of exam scenarios, you might actually have a case whereby the nominal wage might change after, say, maybe X units of work. Okay, so let's assume that at this point it's going to be X. So this is where the budget constraint is going to become steeper. So you have a kinked budget constraint. Okay, so it's actually quite simple, the dynamics of the budget constraint here. If you don't understand this, just simply go back to your consumer theory basics and you should be able to figure out how the budget constraint is going to move and how it's going to be kinked and things like that. Okay, now that you understand the dynamics of the budget constraint, we can now go on and derive the labor supply curve. And the labor supply curve is going to be plotted on a graph with either the real wage or the nominal wage rate on the vertical axis and the amount of labor on the horizontal axis. It's not leisure, but it's labor. Okay, but for our case, we're going to be using the real wage for the vertical axis. Okay, so very quickly, just let me set up my initial equilibrium. So we're over at point A and we're having L naught amount of leisure. So now the nominal wage is going to increase, causing the real wage to increase. So we're going to have a steeper budget constraint over here. And let's see where this individual might end up. So let's say this individual, after getting paid more, he wants to go to, say, maybe point B. So at point B, which is his new optimal bundle, he's going to be having less leisure. So as you can see, initially he was working this amount, and now he's working more. So with a higher pay scale, he's sacrificing leisure for more work. So here you can see that when the wage rate increases, there is an increase in the labor supply. Well, this makes sense, right? You pay people more, they will want to work more. But let me tell you, this is only true when there are two conditions that are satisfied. So let us try and find out what are that two conditions. So what I'm going to do is I'm going to use the imaginary budget line over here, and I want to find out what is my substitution effect. So I know that if I move to the right side of point C, then leisure is a normal good, and if I move to the left side, then leisure is an inferior good. Well, of course, because when the real wage increases, then your real income is going to increase, so more of leisure means it's a normal good, right? So as you can see, the new point B landed at where leisure is a normal good. So that is one of the conditions. The first condition is that leisure must be a normal good. So there you can see I've marked out my substitution effect, and this is my income effect. So the other condition is that when the income effect is actually lesser than the substitution effect. So these are the two conditions that you need so that when the wage rate increases, the labor supply is going to increase. Now, let's see if one of these conditions fail. What if the income effect is more than the substitution effect? What is going to happen? Well, just a little quick one. What you should expect is that when the wage rate increases, then the labor supply is going to fall. Well, this might seem a little bit counterintuitive. If I'm going to pay you more, why are you working less? Well, we'll go through the intuition later. Let's look at the mechanics of the graph first to identify how is it possible that with a higher wage, you can be working less. So what I'm going to do is I'm going to draw the graph that you just saw. So I'm going to draw the first increment in the nominal wage in black. So we are now going to start at point B, okay, after one round of increasing the wage level. So what I'm going to do now is I'm again going to increase the wage rate, which causes the the real income to increase as well. So we have a steeper budget constraint, right? So now we're going to find out which is our new point B. So let's say this is the imaginary budget line, and that is our new point C. Okay, so we're going to draw a vertical line down point C, and if we go to the right side of point C, we now know that leisure is a normal good, and if you go to the left hand side, leisure is an inferior good. Well, that's because the real income has increased. So this over here is our substitution effect, that small little red arrow there moving to the left hand side. And let's have an income effect that is maybe this big, so that this is larger than the substitution effect. So this larger income effect will bring us to point B over here. And what you should notice is that the new optimal point actually shows that this worker is working less. So as you can see, this is when the wage rate increases, but the labor supply falls. It's very clear that this individual is working lesser. And this is the case when leisure is a normal good, and when the income effect is larger than the substitution effect. So you can see this is different from the previous scenario that we had. But why is it so that when the wage rate increases, then the labor supply is going to fall? Let's take a look at the income effect. So what does the income effect say? Well, the income effect occurs when the individual decides on the quantity of leisure based on his new real income. So at this point, he chooses to increase the amount of leisure he has because he is rich enough given the new real wage level. So he chooses to work less to enjoy more. So understanding his new amount of real income, he understands that, okay, right now, looking at my income, I think that I can actually substitute work for leisure because I've got enough of income. So just let me run you through a numerical example on why there's this intuition behind the reduced labor supply. So let me ask you this question. How much money do you think you need to live your dream life until the day that you die, assuming that you don't have to work anymore? Okay, you just gotta enjoy your life until the day you die. Let's just assume that you need $100 million to live that dream life until you die. So if I'm gonna offer you a job where the nominal wage rate is $10 million per year, you would actually work for 10 years so that you can earn that $100 million, right? But now if I offer you another job that is paying you $20 million a year, then I guess you're only going to want to work for 5 years, right? So this is where the labor supply is falling. See, you are supplying less labor for a higher pay. So this is where the income effect is larger than the substitution effect, and it causes you to actually work less. So initially, when the nominal wage was W0, we were over here at point A. And then when the wage rate increased, it went on to point B. And when it increased again, it went on to the second point B. So joining the dots together, okay, what you will notice is that you have derived a curve to derive the labor supply curve. What you should understand from this curve is that when the nominal wage increased for the first time, you actually supplied more labor. Then when it increased again, you actually supplied less labor. So it's from more and then to less. So if I were to plot this on a graph with labor on the horizontal axis and your real wage on the vertical axis, you will see that it goes from more to less amount of labor as the wage rate increases. So this red shaded portion of the labor supply curve is known as the backward bending supply of labor. And I just want to remind you that L over here on the horizontal axis refers to the units of labor, not leisure, okay? And here's a quick recap of what we have learned, which is essentially the most important thing of this entire chapter, is that when the labor supply curve is outward sloping, that's when leisure is a normal good and the income effect is lesser than the substitution effect. And when the labor supply curve starts to be backward bending, that is where leisure is a normal good and the income effect is larger than the substitution effect. Whoa, okay, so that's all the time that we have for this video. We have completed chapter 5 and I want to thank you for studying with Quickienomics.